Hey again, everybody. It's Rainydan. We're working on getting our way into Gas City. Um, on the previous videos, if you recall, introduced myself and why are we doing this big project? And I think it's because there's something interesting here that we want to get to. We want to be able to figure out not just how this car, can be driven, but we're going to drive it somewhere. So stay tuned for that, of course. We went through the first three tutorials in Gas City, cities and rigs, agents and sessions. We learned a bunch of commands, and now we're going to continue through these. And I've got about an hour here, so hopefully we can get through the last four of these tutorials. So let's give it a try. Okay, we saw how to peek at agent output, attach and nudge. Right, and now we're having agents talk to each other. Okay. Let's see, we should have a city running, agents for mayor and reviewer. So if you recall, we called our city tutor. We made this rig book show, and we have a butler and a stickler. We have definitions for all of those things inside of our agents for tutor. Here they are, mayor, butler, and stickler. The stickler was someone who would judge our bookcases. The butler was somebody who would review our code, make sure everything is clean, that kind of stuff. Okay, so let's go with this. Okay, just a sec. So up to this point, right, we've been doing our sessions, we've been dropping into the mayor, we've been sending messages like one-shot text and that kind of thing. So let's try and um, have them work together. They don't usually call each other. There's no shared memory. They're their own process. But they can coordinate via mail and slung work. Now, I do want to point out something here too, which is that if they are working inside of a shared code base and they're constantly, pulling from main or merging and that kind of thing, they're also going to be communicating by like the content that's getting into the project. Um, but you could imagine that people aren't just sort of constantly like waiting, interrupting themselves. Oh, there's a new design document. I better go read that before I continue with my task. Instead, they're sort of picking and choosing when they're going to come in and out. So let's see. Here, I'm going to turn myself down a little bit. This mic. Okay. The sender doesn't know which session receives a message or who picks up the task. So it's a kind of message passing routing kind of system, I guess. So they can be independent. The mayor doesn't have to actually call the butler on the phone. It just says, I need butler service. The work persists and the sessions come and go. Okay. Mail is how they talk. Sling is how they delegate tasks. All right. Mail. Mail survives crashes, is persistent. Send mail to the mayor. Okay, so here's our first new command. GC mail, send mayor. Please look at something. So we'll have it look at, sure, we could have, no problem, let's just try it. So let's go over here to our window. And it says, this is to the mayor. Subject message, SM. Okay. Now we do have a couple of files inside of our Gas City at the moment. They are, let's see. So we are working on our feedback file. That's sort of our, let's see. Sorry. Let's go back into Book Show. You can see that we've got a few different files in here. We've got this review that was done by the butler and the butler's philosophy. So we could ask the mayor, for instance, to like use the feedback in the review, which is stuff like bug reports, problems, etc., and say like, hey, make some work for these, and then get people fixing them. So let's try that. All right, where were we? Subject. Follow-ups from Butler review. Message. The Butler reviewed the library UI and made some suggestions. Please turn these into a backlog in beads and start dispatching work. Okay. All right, so we've got this message. And this message, as far as I know, is just going to hang out forever. We can check for unread mail. Interesting. So we've got GC mail send. Yeah, let's put this into our let's see here. We had our file. This is sort of like our observations and log of what we're learning, as well as bug reports we might want to make at some point. GC mail send mayor. Was that it? SM. And M, of course, body. Okay. GCmail send mayor. Yep, GCmail check mayor. Okay. So I might have waited too long. I might have already found it. No, it says it's still unread. That's interesting. See the inbox. That's cool. GCmail inbox mayor. Now, it's a little surprising to me that the mayor hasn't already picked this up, because if you... Okay, so this is the one from human. That's me. GC... I would have expected from this, right? The mayor is active, always on. Maybe it's last active 8 minutes ago. Maybe it's just going to wake up eventually and look for stuff. So that's why we want to give it a turn. Okay, GC session, nudge mayor, check mail, and hook and act accordingly. Let's do that. Check your mail and nudge and hook. And act accordingly. Nudged the mayor. Out of curiosity, will we see it? Yep. So right here, the mayor has woken up. You can go back and see if it, checked its email. Yep, there's nothing unread, so presumably it's doing stuff. We don't have to force it to do that. On each turn, a hook will run. Each turn. So to me, the turn means like usually this is like a turn-based conversation that you're having with the agent like Claude. You write in something and that's your turn, and then it thinks about it and responds, and that's its turn. And so it's been waiting for us to take our turn for a long time. So, yep, the nudge doesn't deliver the mail, it just starts a turn. And so maybe it would have periodically done this, like maybe it's on a 15-minute cycle or something like that. I don't know. Okay. Here's what coordination looks like. Once the mayor takes a turn, it reads, it decides the reviewer, and so it should sling the work. Let's see what it did. GC session, peak mayor. And I think eventually some of this stuff is going to like sink in as we use it more and more. All right, excellent. So I read the Butler review before, so this actually looks familiar to me. Um, we got some move, search and find. Cool. So it went through and it started creating tasks. We could go back a little bit further. Maybe we would see it like reading the mail and going, oh yeah, okay, I'll do that thing that you said. No, we didn't go back far enough. Now it's even made even more progress, right? It's doing stuff that I don't recognize totally. GC agent. Maybe it is thinking about dispatching these to a certain agent, and it's also getting help on slinging things. So the stuff that we were doing manually, it's gonna start doing automatically, is my intuition. Okay, it slung a bead. This is the pattern that scales. You send the mail, the mayor does the things, slings to agents, they do the work and close their beads. I guess we could check that out actually. Let's try this. All right, here we go. So now you can see we've got some bugs, we've got some molecules doing work, we've got some other items, polish. So yeah, it went through and it created a lot of open issues. And I guess those are going to start getting done. I don't know. I mean, one would assume. I still find this a little hard to read. It says basically everything is open and this is in progress, which is like leftover from yesterday or something like that. This is priority marking. Priority threes and fours, I guess, not so important. All right. So we talked to the mayor, we sent it mail, and we got it to do something. We got it to read its mail by nudging it. All right, next, hooks. How does this work behind the scenes? Hooks wire the provider's event system into Gas City, so agents can receive mail, get work, and drain their nudges. The minimal template sets hooks at the workspace level, so all your agents already have them. Let's take a look. Let's see if we can find this. I don't think it'll be too difficult to find. Install agent hooks, is that what it said? Ah, okay. I always forget where I have these installed or not. There we go. Did I spell it wrong? No? Hmm. Interesting. Let's see. Yeah, I would have expected to see it in here somewhere. Oh, maybe I didn't. Hmm, okay. Like, for instance, here, let's see here. Okay, so let's just confirm that this totally would work from here. Yes, we got lots and lots and lots of responses. Okay. Books. We're seeing the GC system pack. We're seeing a get ignore. Maybe this one in book show is the kind of most interesting one to check. Ah, This was it, right? Oh, okay. These are just like clawed hooks. These are. I see. They're the kinds of, yeah, like life cycle hooks that you might see. Huh. So for Claude, Fresh Cities right, the manage GC settings JSON configuration. That's what we were just looking at. So that was right here. The GC settings JSON configuration. We got on session start. We've got certain GC managed session hook came on. We got a event out of here. And we've got GC prime dash dash hook. I guess this is what they look like. These are the standard ones. We've got GC nudge train. We've got GC mail check. And here for handoff, we've got GC handoff context cycle. Here we've got GC hook inject. We don't know what all that stuff is. It wasn't covered in the tutorial. But all right, let's see. Let's continue. They'll fire gas city commands at key moments. Yep. So without them, we would have to be typing these commands all the time. We'd be in the loop. But now we're sort of out of the loop. Okay, and that was the end of tutorial 4. Let's record our confusion about the minimal template setting hooks at the workspace level. Oops. Could not find in our city. But did see the hooks in GC. Okay. There we go. And presumably it would look slightly different for some other provider. Okay. So mail and slung beads and hooks. So we finished tutorial 4. Onward. Declarative workflow templates with steps, dependencies, variables, and control flow. Yes, we have been doing one-shot prompts like GC nudge the mayor, go do the thing. GC mail the mayor, look at your mailbox. You know, that kind of stuff. Multi-step workflows are formulas and dispatched as a unit. This thing exists to keep the human in the shell script out of the loop. Fair, totally. I would definitely say workflow for this. Yeah, so formula seems to be like workflow template, if you want. So when I think of workflows, the thing I'm referencing is like Amazon Simple Workflow or step functions, that kind of thing. Oh, hello to the chatter. Just saw your chat. Welcome, and let me know if you have any question. All right. So it's not quite step-by-step instructions. Things can happen in parallel. So yeah, usually when you write one of these workflows, you're not trying to make it linear necessarily. Like first do step 1, then do step 2, then do step 3. Often you're going to do something like first do step 1, then branch out and do step 2 and step 3 in parallel, and then join, perhaps do step 4 after you finished both step 2 and step 3, without saying 2 has to be before 3 or 3 has to be before 2. Right, and so that's a very general pattern we can think of as like a task graph or a dependency graph, um, any recipe could have something like this. Like first mix all the wet ingredients, then mix all the dry ingredients, then combine them. And usually it's not like, well, the wet ingredients have to be done before the dry ingredients. It's just both of these sets of things have to be done before you can put them together, something like that. And there are a lot of things in life that are like this. And especially there are a lot of things in software that are like this, where you'd be like, okay, if I've prepared the data that I need to use as input to this thing, and then that thing is going to run for a while and give another output that'll be used as input for this next thing, you can imagine that you can kind of build these gigantic citadels or internal combustion engines, or all these kinds of things. All kinds of processes could be modeled in this fashion. And so that's what we're talking about here. It's about taking the steps that you would want to do. I think that the interesting thing that we're adding, because we have access to cognition, is that we might be able to do things that before we would have said, okay, you'll run an automatic process here or a program or something like that. And then the human needs to come in and tweak or like evaluate the results. And then some new things might happen depending on the outcome of that. And in place of that human, if you have a really well prompted or trained, agent in there, like a cognition agent, that agent is going to be able to do the step that the human would have done in the past. And so we're going to get the human much more out of the loop. And that's important because if you don't have to wait for the person to be awake or paying attention, um, then that can sort of run in the background. And it can only sort of escalate to the human when you really need the human to do something that the robot just still can't do, or that you don't want the robot to have responsibility for doing. Something like that. Like it says, hand off to the agent to do our bidding. And as we grow our understanding of our domain and the business processes that we want to do in that domain, or the kind of automatic company or dark factory that we want to create, we're going to hand bigger and bigger things off to larger and larger sets of agents. Hopefully, those agents will get better trained and experienced. We'll start building a kind of repertoire or institutional knowledge. And those are the things that are going to get used to do these more complicated workflows. A formula is a TOML file. I don't know what a TOML file is. That describes a collection of steps with dependencies, variables, and control flow. You G-sling a formula to an agent like you would any other work. So let's take a quick digression here. And no, I don't know what's on the Firefox splash page there. An easy to read configuration file format. Okay. Um, this is a top level variable with a setting. This, I guess, would be, these are groups. They're sort of like little namespaces inside of here. This is also a little group, isn't it? It's designed to map unambiguously to a hash table. It has native types, dates and times, booleans, integers, arrays of tables. I guess I don't know what that is. Tables, inline tables. Key value pairs, this would be the key and this would be the value. Arrays, that would be lists of things, like so. And this you can see is a list of lists. So here we have the first thing in this list is another list, and this list has two things in it. The second thing in this list is another list, and it has one thing in it. Here we have a key that has as its value another set of key value pairs, or like a map, or maybe that's what inline table means. Arrays of tables would be like a list, and let's say the third thing in it was one of these. Okay, so I think this is all kind of coming together. This looks very intuitive to me as a software engineer. This is the only thing I don't totally get. Like, it's not clear if these tags are like cascading or I think this. Oh, okay. I think I'm understanding. So imagine that we hadn't named this servers.alpha, but we had just named this alpha instead of being sort of a subdirectory under this servers. It would be a top level one, like owner database servers alpha. But because we've got this dot notation in here, we've nested this alpha group inside of servers. and we've nested this beta group inside of servers. Okay. Um, if that's all there is to it, yeah, then I think that that's actually plenty of understanding for me. But let me know if you have any question. Okay, toml files. Suggestion. Link out to the authoritative definition app. Oh, oops. Oops. All right. Back to the tutorial. Okay. Formula files use a toml extension. To follow along, write a pancakes recipe. Oh, okay. So they're actually going to take us through here. Ah, okay. Interesting. Okay, so let's look through this example. Um, isn't that funny? I was talking about dry and wet ingredients. I swear I hadn't read this web page before I was starting talking about it. But yeah, clearly cooking a good metaphor that everyone recognizes for this. Okay, so we've got making pancakes. We've got a step of dry ingredients, title and description. Uh, and we can kind of go on and read that description. Notice that unlike this third one, it has no needs, it has no dependencies, so it can be done if you've got your flour, sugar, baking powder, and salt. Here we've got some wet ingredients, we got some eggs, milk, and melted butter. And then this one combined, it's like you need to have done the dry thing and the wet thing before you can come do the combined thing. Oh, oops. I'm not trying to ask a question, no. Okay, after we've combined everything, we can cook, and after we've cooked, we can serve. Yeah, okay. Waits. It says waits for, it's really like, I don't know. I almost want to say blocking. Not quite, I guess. Without these needs declarations, everything could happen at any time. Well, what would really happen is that you would try to do the cooking of the pancakes, and you would go to look for batter and you wouldn't have any, because batter is kind of an output of this combining step, right? And so being able to, so this is sort of a philosophical thing about how you define workflows, which is, do you define the dependencies by saying first this activity is going to happen and then this activity is depending on that activity happening? Or do you say, well, I don't need this activity to happen, but I do need the product of this activity to have happened. So the input to this thing, it might actually be not that this happened, but that the product of it, the dry ingredient mixture, is available. Because, of course, you could have done this like a bunch of times somewhere else. And you could have stuck a bunch of mixed dry ingredients on the shelf that say, pancake dry ingredients. And when you came down to this step, instead of saying, well, did you mix the dry ingredients today? You could say, do you have any dry ingredients on the shelf for me? Right. And so different workflow systems do that in different ways. But one of the ways that I'm familiar with is this sort of like I'm waiting for the promise of this activity, which is kind of like the output, maybe, to be fulfilled. And then I have this, if that promise is fulfilled, then I have an expectation that these dependencies that I need are going to exist somewhere. Um, so yeah, I don't know if this is a super useful distinction for everybody, but for me, it's making me think about, do I like this workflow system that is obviously like really lockstep with being served with a sequence of events? Or would I prefer a system that, allows me to deal with inventory or something like that? Maybe there would be a way to do my step that said something like, check for dry ingredients on the shelf. And if there's no dry ingredients, then mix some dry ingredients. Maybe they're going to get into that kind of stuff. Okay. So we've got our workflow system defined in TOML. Notice that the dependency things right here, they had this particular notation, double bracket notation. I don't know why that's important, but I assume it's important. We've got arrays for our dependencies, and then they just had some text for title and description. Oh. I keep I keep selecting text and it keeps wanting me to look at the assistant. Thanks, but not yet. Okay. All right. So we went through all of that. Inspecting formulas. There are already some. Well, that's interesting. Now, where did they put this? Formulas, pancakes, TOML. Okay. So if we look in our city in formulas, we're going to find some formulas. So let's do that. No? Interesting. Um, Perhaps those are city scope formulas. Ah, okay. So now we have a bunch of formulas. So these came out of the box in our default configured city. So the default, if you recall from yesterday, if you GC into the city and you do just the default, it doesn't necessarily have all the configuration that you'd see in a gas town. There is like a specific gas town pack that gives you all the bells and whistles of that and all of its sort of unique configuration. But we've got a bunch of these. Molecule do work, do some shutdown. These dogs are kind of wandering around the city, making sure people are doing what they're supposed to be doing. We've got polecats that are committing work, I guess. Um, we're checking on the status of the Dolt database. Dolt is like the get back database where all of our beads are living. This is like not in the tutorials, but just information I had. I don't know what this one does. Let's see if we can learn more about these. GC formula show. Okay. That's weird. I really wish that this was actually showing like the fork join stuff. Um, but let's see. Maybe that's a this is a feedback I think from me. Depict dependencies in DAG. There are ways to so DAG is short for directed acyclic graph. It's a way of talking about task graphs like this one that have they form a graph of directed edges of dependencies if you want. Okay. So let's see. GC formula show molecule. Let's just see. I'm just picking one at random. Polecat commit. I don't know what a polecat does when it commits, but apparently it does this. Ah, it's actually been documented as well. Ah, so this is to we haven't had the word refinery defined yet, so I'll skip that for now. Designed for small installations where merge review is unnecessary. So you wouldn't want to do this in a public project where every change is going to be human reviewed. You would want to do this if you just want the polecats to just whap changes on top of each other as fast as possible. Receive work, follow the steps, commit to the base, push, close bead, and exit. And that's it, you're done. It's interesting that they had to put this in. They've double emphasized exit and gone. Don't use feature branches, just commit to main or master or whatever you call it. Push conflicts are going to be handled by just retrying. Okay. If you get blocked, if there's a push conflict, merge conflict, then you're stuck. If you're full of context, then request a restart. So as a polecat, I don't want to be wasting time like trying to work with the last vestiges of my context window. There are certain like characteristic failures that happen as agents run out of their context window. Their performance starts to degrade. They start trying to swap or get ready to compact the conversation, that kind of stuff. And so generally, there's like a performance that starts tailing off as the context window fills up. With like million token context windows in Opus 4.7, I don't know if that's super realistic, but I don't think the polecats are running Opus 4.7 either usually. Uh, let's see. Gotta have, so these are all template variables. We talked about this briefly, but sort of about you need to know what you're working on. You need to know what is the base branch, what's the build command, and so on. And what does it do? It loads context, sets up its workspace, does tests, implements, self-review, and commit and push. So that's how a polecat commits. Hopefully, so we can get into the nuts and bolts of this, but I was just using it as kind of an example. GC, formula, show, whatever. I think that's the one we use. Okay. It compiles the formula by arranging the steps in the dependencies. So out of curiosity, did we have steps and dependencies? I think we did, but I wasn't paying too much attention to that. Okay, so workplace setup needs load context. This needs workspace setup. This needs pre-flight tests. They're all saying they need the one before them. So this is actually an aggressively linear workflow. It says you have to finish step 1 before you move on to step 2, and so on all the way through to step 6. Keep using the mayor from the early tutorials and add a generic worker so that you have a second execution target besides the reviewer. Sure, we can do that. Well, in tutor times, they wouldn't have grunts, right? They'd have peons. So let's have a peon. Let's see. Is it name? Name, peon. All right. Yep. The city defaults to Claude, and it doesn't need a new agent toml yet. The reason we write formulas is to see them do things and then sling them to an agent. So one thing I find confusing about this example is like we could have made this pancake recipe up here and we could have slung it to the mayor. But what was the mayor gonna do when it's like, well, I want to mix the dry ingredients, but they don't exist, they're not a thing. Um, let's see. Uh, hmm. Maybe we could make a formula about let's go over to our mirror for a little bit. Let's make a formula to create a bookshelf based on science fiction award winners. Uh, the formula should take a year, a range of years. How about range of years as input? And create a virtual shelf with the winners, take a range of years with the winners of the major science fiction awards: Hugo, Nebula, Locus. World Fantasy Award? Worldcon? I guess I'm showing my ignorance a little bit. Let's just go with these three. Okay, so now we've got our mayor trying to make a formula for us. This is just my laziness. We could probably, you know, have it do. We could probably have written this thing. It would have said something like, you know, award winners. Would have been the name of our formula. It would have taken this necessary input. Then it would have executed library.py, something like that. It would have created these shelves. I'm not sure what the storage system is yet for this library program that we wrote inside of this tutor. Let's see what the mayor does with this. I'm curious. I haven't seen this note before. Almost done thinking with max effort. Because I haven't really been using my city/Claude in anger yet. This is an interesting tip, right? Use get work trees to run multiple Claude sessions in parallel. In a way, that's what we're trying to do with Gas City. Um, but this is sort of a very Claude centric way to think about solving this kind of problem. Um, Work trees are essentially, you could think of them as like project branches where the different sessions are not scribbling on each other. Um, in the world of Git, like on the local file system, whatever branch you're in, it's actually changing kind of what's visible to you in the file system. And so if you had two different agents running at the same time, they couldn't be in two different branches. They would both be overriding each other's view of what's the branch in the file system. Okay, so let's see what happened. We got molecule SF awards shelf. We've got year start and year end. We got shelf name. We've got build shelf to drain. Interesting. Research and populate. That's an interesting way to put it too, right? Um, you can sling it to the butler. We could just sling this to our peon too. All right. Let's try it. GC sling, book show, peon. This is so old school, right? I'm just typing things that I could have copied. Formula mall SF. Awards shelf. Bar year start. Oh, whoops. Year underscore start equals. Bar year end equals 1972. Oh, interesting. Do I just do peon? Did it need to go to the butler? I don't actually know. Here, while it's doing that, let's actually go and look at the formula. We're in book show. There's a readme and there's a library. There's a shelf name. It's going to be stashed in shelf. Research the winners. Read a compact plan to standard out. Interesting. Verify the shelf and emit a summary. Run this command and nothing else. Now, it's interesting that instead of making like a list of steps that are like, before you do this, before you do that, do that. It said, you know, it just went, do this 6-step process. I guess the next thing we should be looking at is how this thing is getting along. Library.json. I guess this is the library. Let's see. Well, we can also check if it's working hard. Let's see here. Oh, whoops. I keep forgetting the difference between list and show. There's a couple of peons running. Oh, okay. So this is actually in progress. And it's like it did one big step for us that has all those 6 sub-steps inside of it. Not the right intention, I think. But it looks like it's in progress. So it is actually doing what we wanted it to do. Let's make a clarification. I don't know what happens if you change a formula as it's being executed. That would be kind of weird. I would assume that the formula has already been kicked off to the peon and it's executing it because it's already doing steps inside of it. But in other workflow systems, changing horses in midstream like this, you'd be like, you'd cause a problem where you might do the first half of one workflow and then the second half of a different workflow, and they might not be compatible. And so a way to solve this problem is to version the workflows against each other so that while you're doing workflow version 10, all of your agents and such are looking at that definition. And you can start running workflow version 11 and it won't look at all the stuff that was in version 10, and the new agents won't see the definition for version 11, so that they can have those different perhaps workflows and both be running simultaneously. So you can kind of migrate forward from one version of a workflow to the next without stomping on the in progress workflows of another version. Of course, we could just wait for all the old ones to be done too, then cut over. All right. See, I sort of felt like this would be the place where the work would get down to business. Um, let's look at this one. Now, I'm curious if it's going to end up with nominees or actual award winners. I'm curious about a lot of stuff, but anyhow, while we're waiting on that, okay, okay. This compiles the formula, creates work items, routes them. Okay, so that would be to the mayor, and creates a convoy to track it. Sling has this full lifestyle or life cycle. Okay, when you sling a formula, the result is a wisp, a lightweight ephemeral bead tree. That's like an instance of the formula. So yeah, it's helpful to think of the formula as a template, and then the actual execution of that or the instance of that is a wisp. Okay. Only the root bead is materialized in the store. The steps are read inline, and they are garbage collected after they close. That would usually be the right choice. I guess if you want to be able to audit all of the executions that you've ever done, then you would not want it to be garbage collected. You'd want it to live forever. For long-lived workflows where multiple agents work on different steps, you want a molecule. Every step would be its own bead. Use GC formula cook to create a molecule. And then the individual steps are going to get slung. Okay, that's interesting too. Okay, so we had a formula, we had a wisp, which is more like a one shot. I guess if it would have made sense for me to talk about atoms too, although atoms have a really particular definition inside of computer science. But yeah, I mean, that's kind of the idea. It's sort of that we zoomed in on this wisp and we reified or made real all of the things inside of this formula. So each step is its own unique thing. Use GC formula cook to create a molecule. Let's do that. Mol SF awards show. Although that's unclear. Oh, okay. So this would actually um, molecules are also instances. Okay. So you wrote this formula, it had a bunch of steps. And then this one is like, I want every single step in this thing to have appropriate dependencies, I think. Now it's interesting. I don't know. In this example, it seems to me like the beads that go with these steps should follow the dependency order. So that, for instance, um, serve depends on cook, cook depends on combine, combine depends on dry and wet. And there are ways to write those dependency relationships inside of beads. And I'm curious if that actually got done when this formula was cooked. Uh, okay. do the beads that are created inherit the dependencies that are in the needs of the formula? And it's kind of interesting too. If you're like, what if you felt like every time I see this thing, every time I see this formula, I want it to be done as a molecule instead of as a wisp? Do I have to remember to cook it every time instead of, I guess, slinging it? Um, Also, it's mildly annoying that it doesn't say. Um, uh, so you see how in this command we're saying we're slinging and we're sending it to the mayor. And the thing that we are slinging is pancakes, and pancakes is a formula. And then down here, we're saying um, this thing is a formula and it needs to be cooked, i.e., turned into a molecule. And the formula that's going to be cooked is pancakes. And then finally, we're slinging those down to certain workers. You know, maybe it's like as a person who enjoys languages and syntax and placements, it's like the verb and the object and the indirect object and stuff, they're all getting switched around. And, you know, uh, I assume this made a lot of sense to agents or someone. um, but yeah, so in this one, for instance, we're slinging to a worker the pancakes. No, no, no. Okay. I guess in this one, we're slinging to the mayor the pancakes. All right, let's go talk to our mayor about this for a second. One feature of formulas seems to be a dependency ordering between the steps. Seems like the formula could temporarily store intermediate results or pass its outputs as inputs to a later step. Um, but our formula writes all the steps into one big prompt. Criticize. Should it look different? So I tried to talk to agents to sort of give them an idea to fix their own mistakes. Um, Also, questions, criticize my idea. I find that they perform a lot better when they are like not just telling you what you want to hear, but where someone is pushing back on them or disagreeing with them. Use agents to optimize specific tasks. We'll definitely get to this. Like, this is one of my big goals for Gas City. Um, let's see. Are you familiar with GC Formula Cook? This allows a formula here. I also like to do this as well. We're going to make it easy for the agent to understand that this is a command that's going to be executed. This allows a formula to be split into dependent beads and executed by independent agents. And executed by agents. We could refactor with this possibility in mind. Go ahead and refactor. Okay, so it's going to learn kind of what we learned from the tutorial. Like a function, a formula can be parameterized. So I think this is talking about the computer science concept of function. It's not a particular term of art inside of Gastown or Gas City, as far as I know. No one's defined function. Um, it just means in computer science, a function just means that you take some inputs and then you do some kind of logic or some sort of action, and then you return some outputs. Um, and so what they're talking about here is that it wouldn't be useful to have a function that just was like pressing a button, right? That took no inputs and just did one action. It's more useful to have a function that could take many different inputs and do different things depending on its inputs. Um, so like a calculator that can add 1 plus 1, but can also add 1 plus 10 or 1 plus a million or any inputs that you would like to use to the plus function. Right? Okay. We did get some vars in our formula. If you recall, we got vars around the time range. Yeah. Yeah, okay. It confirmed. I don't know if you caught that, but it said that it confirmed that the oh oops, sorry. It's this is my fault. I'm like scrolling the window and this kind of stuff. So I was trying to just like roll up and down, but there we go. Okay. So it actually made a 4-step DAG. That's great. Control B question mark. There's something that we do to start scrolling. I totally should just know. But P page, previous page. Okay, I guess page up. Okay, let's try that. Okay, there it goes. But it's showing. Well, I was like, I rolled up the mouse wheel and it's gone through all these like things that it showed. But let's just look at what the mayor said and okay. Hit escape and now we're no longer in scrolling mode. Okay, I'll try to remember that. Refactor to a 4-step DAG. Research, populate, verify. There's going to be a JSON manifest in the temp directory inside of the .gc directory. Okay, that's cool. Produce by research, consume by populate, and verify. Nice. Okay. Well, that's cool. I'm glad it did that. Awards shelf. We've got our vars. Let's try your start. I wonder if it would, if we didn't fill in year end, if it would just, if it would know to just use only that 1 year in the range. Before I move to the file, it looks like that it happened. Okay. Where were we? Okay, here is our old workflow. And now let's look at the new one. So drain needs verify. Verify needs populate. Populate needs research. Now I'm curious. It might have. Oh yeah. And lastly, like what's the variable that's needed? Year start, year and shelf name. Okay, so let's do that. 1989 forever. Oh, oops. Okay. Let's see. I just made. Ah, probably slightly wrong. I'm gonna have to get going soon. Let's see how much more we have in this tutorial. So we were passing these var. Ah, okay. We could have done sort of a dry run with the variable name is Alice. We can write defaults into variable names. Interesting. We can like type check our variables and so on. Interesting. Yeah, we did pass that. We can preview it. Yeah. Steps can fan out. Yeah. Test and review, wait for implement. I think I was talking about that earlier, forking and joining. And then you can group related steps under a parent. That's interesting. I don't know why you would do this. Oh, okay. It's I see. So they could see in parallel. You don't. Okay, yeah, yeah. I'm sort of familiar with this problem. It has something to do with like if you need 10 things to happen before the next thing, they're all in a group, and so you could say the I'm depending on this group to be done. A convenience for large formulas. Now this is another interesting concept as well, where you're like you know, I'm making this large formula that is covering this really long workflow, this really large thing that I'm trying to do. At what point do I need to modularize that and split it into different workflows that call into other workflows, right? And so this concept is really interesting. We're going to have to think about when you would want to do this versus, you know, make a workflow that kicks out other workflows, make a formula that causes formulas, that kind of thing. Yeah, and namespacing is good too. Oh, okay, I see. We're most of the way through this tutorial. Let's just try and power through. We don't have to like execute all the examples just to kind of get to the end of this one, I think. Non-sequential, non-deterministic order. That's the sort of execute in parallel concurrency kind of thing. Um, do this only if this. So that's nice. Um, so this is like skip. There's no complex expression language. If you need more sophisticated branching, then you know, start doing different steps and that kind of thing. So meaning we can't say like environment is staging, or environment is production, yeah, etc. You know, and then loops. So this is like a Turing complete workflow definition language, I guess. Um, that meaning you could execute any program inside of it if you tried really hard. Um, yeah, this time they've just used for retries. Uh, there's a sort of famous macro in Lisp called loop that can loop through things so many different ways. Like, I don't know, a dozen, maybe more, probably more, um, with all kinds of interesting, first time, last time, you could write a whole program inside of loop essentially. And it's not clear how complicated this one is. It looks like it's very simple. uh, so I guess this would be like an assertion thing. Did this work? I assume that it would want to write out that to somewhere. If the script exits 0. But if all attempts fail, then the step fails. Okay. And that takes us through formulas. There was some complicated stuff here near the end. I definitely don't think that we got a full understanding of all the things that are possible with loops and conditions. Um, but yeah, I can understand like why you might want this or when it would be like convenient to have it. Um, and certainly like it should grow according to the actual needs of these workflows, right? This should be like a real example if you're going to overcomplicate loop with like loop until certain condition has obtained, or give me a complicated condition that's necessary to drive this step, that kind of thing. And usually you don't want to do that. Usually you want them to be more transparent and readable than that. Okay. All right, I gotta hang out, but I'll see you next time. Maybe we will cover some of the control flow stuff down in formulas, or move on to the final tutorials about beads and orders. So, as always, thank you for watching. I'm gonna put these on YouTube too, so if you missed anything, feel free to check them out. That's Rainydan, signing off.